Hey everybody, we're picking up in 3.4. We're going to do a little bit more solving some equations, and the big difference here is that we're going to have variables on both sides of our equation. This is something that actually comes up pretty commonly, and we're going to still use all the skill sets that we've worked on and used up to this point, but we're going to definitely include a couple extra ones. Let's take a look at two really simple ones. We're going to start here with number 6, and then just to give us a little bit of complexity, we're going to go ahead and do number 12. Those are the two that we're going to do today. So question number 6, we've got 8 plus 4m equals 9m minus 7. The first thing that we want to do is acknowledge we need the m's to be together, or we're not going to be able to really move forward. So when I look at this, I'm really trying to pick out which m is bigger. Now, again, it doesn't actually matter. I can move either one of them. But for those of you who don't want to deal with negatives at the end of a problem, it's generally good to move the smaller m. So I'm going to minus 4m from both sides. On the left, that m is going to zero out, leaving me with just an 8 equals 9m minus 4m would be 5m minus 7. Now because the m's are on the right, I want to move all my other numbers to the left. So I need to now move this 7 over here. Now you could do those two steps simultaneously if you're really comfortable with the algebra, but not necessary. 15 now equals 5m, and if I divide by 5, m comes out as 3. And that's it. The big step is that initial move everything to one side. Number 12 has a slightly different issue. We'll keep working over here, number 12. It has an issue of distribution followed by all of that kind of movement. R plus 7 equals 5r plus 59. So we really need to distribute first. That's again one of those things we learned in 3.3. Distribute, clean up the parentheses so that we can just combine like terms. That's going to give us 7r plus 49 equals 5r plus 59. Deciding again which r is bigger, I'm going to probably move this 5r minus 5r. And I'm going to show you what I mean by you could do them simultaneously. Okay, that's moving my r's to the left. I could move my 49 to the right at the same time. You could do this in 2 steps. There's nothing wrong with that. Or you can do it all at once. Do not overwhelm yourself with too much work to do at the same time. But you get 2r equals 10. And by dividing, we get r equals 5. And we're done. There is one thing that comes up from time to time. Sometimes when we have a variable on both sides of the equation, we end up with something that's actually not solvable. It's not that common in the textbook world, but it does come up fairly regularly in the real world where there are problems that just can't be solved. And I'm going to give you an example of those. There's some that can't be solved because there's no good answer. There's others that can't be solved because there's too many good answers. So let's take a look at a couple of these. We're going to look at number 23, and then we're going to take a look at number 24. They're two of our special cases. First thing we're going to do here is we're going to go ahead and do our distribution. This whole equation would then be 2 minus 15n equals 5 times negative 3 would be negative 15n. And 5 times 2 is plus 10. At this point, I need to move one of my n's. I'm going to go ahead and move my n to the left, so I'm going to add 15n. Add 15n. For the most part, guys, these will be solvable, and you'll see that. But something just happened. N on both sides canceled out. There are no n's left. That leaves me with a 2 on the left equals 10 on the right. Now, I don't know about you, but I'm never going to trade someone $10 out of my wallet for $2 in theirs. That is not an equality. This is not true. So I'm actually going to slash through that and say that there is no solution to a problem like that. If the n's cancel and you end up with something that is false, like 2 equal to 10, we know it's not true. But watch what happens when we do number 24. If we distribute, we get 12y plus 6. On the other side, we have 12y plus 6. You guys notice that the equations are identical? If I minus 12y from both sides, it will cancel on both sides. And that will leave me with a 6 equal to a 6. When that's the solution, I never figured out what y was, which means y can be any number. That tells us that there are infinitely many solutions. That symbol right there is the infinity symbol. That tells me I've got that many answers. Pick a number, any number you want to put into that equation for y, use it on both sides for y, and you have a true equation. So that will happen from time to time. The rest of the assignment, you'll pretty much have just straightforward answers. But if you have questions, come ask, shoot me an email or shoot me a message on Teams. All right, we'll see you in class. Bye.